All right, well, welcome. What I want to do is I want to introduce what we're going to be doing for our first examples of the chain rule. The chain rule is a rule that we use to calculate derivatives when we're evaluating a composition. So if I have a function, and it's a composition of two functions, g of x composed with h of x. In other words, if I take x, the first function it sees is the function h. That creates a new answer. We take that answer, we use another function, g, and we get our final value, y. Y is g of u, and u is h of x. So this is the idea of a composition. The chain rule is what allows us to calculate derivatives of these formulas. If I think about this in the language of a chain, u is the function h of x, I can calculate the derivative of u. If I think y is a function of u, I can calculate the derivative of y with respect to that variable. Now u came from h of x. So this is g prime of h of x. The chain rule says the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. In the language of functions, that says take g prime, but still evaluate it at h of x, times h prime of x. The most common mistake is that students want to put the derivative inside of g prime, but that's not correct. Okay, so what we'll do is we'll look at some examples of this. All right, so let's take a look at how we would use the chain rule to find the derivative of this function. First, let's identify what the composition is, or in other words, let's find the chain. So if I think about my function f of x as 2x minus 1 all raised to the fourth power, and I want to think about that as a composition, then what I want to do is I want to think about, if I take my input x, what do I do to that? Well, first I multiply it by 2. And then I take that and I subtract 1. And then I take that answer and I raise it to the fourth power. So those are the steps that I'm thinking through. If I thought about that as a composition of functions, what I'm doing is, in the first step, I'm taking an input and I'm doubling it. In the second step, I'm taking my input and I'm subtracting 1. I take my input and I subtract 1. In the third step, I'm taking my input and I'm raising it to the fourth power. Now, if I thought about those and considered what functions I know how to take a derivative of, the key transition point is when I raise it to a power. So I'm going to be thinking about the first two steps as my initial function. I take x and I double it and subtract 1. And I'm going to take a second function, g, will take that input and it raises it to the fourth power. And so what I'm thinking of is I'm thinking of a chain of the functions h of x takes x and gives an output of 2x minus 1. G takes an input, let's call it x this time, takes an input and it raises it to the fourth power. Those are my composition functions. My function f is g of h of x. In other words, I'm putting 2x minus 1 into my function g to get an output. Now, I want to emphasize the idea of substitution again. H of x is a function. It gives a value of 2x minus 1. So I've substituted h of x for the formula 2x minus 1. Once I've identified these functions, I can compute their derivatives. Alright, if h of x is 2x minus 1, I easily know the derivative of h. That's a line. Derivative gives the slope. For my second function, g of x equals x to the fourth, that's a power. The derivative is 4x cubed. Now, 4x cubed is not literally the slope. 4x cubed is a formula that gives me the slope of the function. All right, so let's now think about the chain. My chain says I have a function, y is my function of x. And we're going to think about this in steps. First, we'll define u is the inside function, h of x. And then we'll say y is the outside function, oops, I meant to say g, of my chain variable u. So u is equal to 2x minus 1, y is equal to u to the fourth power. Let me try to make a little bit of a connection for you here. 2x minus 1 to the fourth power. What we're doing is we're saying, our function is 2x minus 1 raised to the fourth power. So if I imagine covering up 2x minus 1 and replacing it with u, so that we're calling what's inside that purple box the formula u, I'm thinking now of my function of x as a function of u where u is a function of x. And so if I think about the idea of the chain rule says the derivative of y with respect to the original variable x, dy dx, is dy du. In other words, the derivative with respect to the intermediate chain variable times the derivative of the chain variable with respect to x. So, what is dy du? Well, dy du is just a chain rule, is a power rule for u cubed. And I should probably be using double arrows here. Let's change that. Double arrow means implies. Du dx is the derivative is 2. And so the derivative of y with respect to x is the derivative of y with respect to u, that's 4u cubed, times du dx, which is 2. Now the last step is I have to go back and change u into its original formula. U equals h of x, which is 2x minus 1 cubed times 2. So I've taken my u and I've put it back to the original formula. So my final answer, dy dx equals 4 times 2 times 2x minus 1 all cubed. In other words, it's 8 2x minus 1 cubed. Right, there's my derivative. In the language of the function chain rule, what we've done is we've said f prime of x is g prime evaluated at h of x times h prime of x, where g prime is this function that cubes the input and multiplies by 4. So we will cube the input and multiply by 4. And h prime of x is this function that takes the input and gives out the answer of 2 all the time. Now h of x happens to be the input, 2x minus 1. So our final answer is 4 times 2x minus 1 cubed times 2. That's the example of the chain rule.